3-point charges with charge Q equals 1 times 10 to the negative 15 coulombs are arranged in an equilateral triangle. The Q's are distance L. So let me erase this. The Q's are a distance L away from each other and a distance D from the center of the triangle. We're going to neglect gravity for this problem. So what is the electric potential created by the 3 charges at the center of the triangle? Well, all you remember for this problem is V equals KQ divided by R, where R is the distance, Q is the charge. So you want to find V total, which equals V1 plus V2 plus V3. So just however many charges you have. I'm going to call this 1, 2, and 3. And we're going to the center. So from 1 to the center is distance D. From 2 to the center is some distance D. And from 2 to the center is distance D. I'm sorry, I think I said 2 twice. Doesn't really matter. Anyways, so V total equals KQ. Remember, the Q, or as up here, Q1 equals Q2, which equals Q3. Therefore, I'm just going to call it Q. Sorry. Therefore, we're just going to call it Q. So, divided by D plus KQ divided by D plus KQ divided by D. So, V total equals 3KQ divided by D. Let me just move this out of the way. All right, next problem. What is the electric potential energy shared by the 3 charges? So that's U. And U equals the summation I, J, where I cannot equal J, K, Q, I, Q, J, divided by some distance, all this times 1/2. Well, this is a formula. We're not really going to use this. I mean, we are, but we're not going to. The reason multiply by 1/2 is we get repeats, so I'm not going to do the repeats. All I'm going to do is I'm going to say U equals the K from Q1 to Q2 divided by, well, what's the distance from 1 to 2? It's L. From 2 to 3 is also L, and from 1 to 2 is also L. So, divided by L plus KQ from 1 to 3 divided by L plus KQ 2 to 3 divided by L. And you see the reason I don't include the half is because what happens here is you end up getting plus KQ2 Q1 divided by L, where this is exactly the same as this, and I'm not gonna do that. There's no reason to. Just realize you need to do it for each of them from one to the other, from one to the other, from one to the other. So my final answer, oh, by the way, Q1 and Q2 and Q3 are exactly the same. So it's KQ squared divided by L plus KQ squared divided by L plus KQ squared divided by L, which equals 3KQ squared divided by L. That's the answer. Now, the charges on the top, the charge on the top remains fixed. The 2 bottom charges start from rest and are allowed to move. So let's think about that. V naught, our initial velocity, is 0 meters per second. After a very long time, what are the speeds of the moving charges? So we need to use delta K equals negative delta U. So let's address it. What is delta K? Well, sorry, I was taking a drink. We have some K final minus a K initial. Well, K final is 1/2 mass velocity final squared minus 1/2 mass velocity initial squared. But this is only for one of the moving objects. We need 2 of them. And their velocities and their mass are exactly the same. So we can either just multiply this by 2, or we can say plus 1/2 mass velocity final squared minus 1/2 mass velocity initial squared. Now, so this is for Q1. I'm going to call this Q1 and this Q2. This is for Q2. Well, we said our initial velocity, they're starting at rest, is 0. So that is 0. And that is 0. Now I just need to add up. 1/2 plus 1/2 is 1. So I have delta K equals mass times the velocity final squared. I'm not going to do that. I'm going to do it like this. Now I need to say, I'm just going to draw a big line all through the center of this page. What is delta U? Well, delta U is some U final minus a U initial. Well, what is U initial? Well, we found U initial right here. Remember, U equals whatever that is. We found U initial. U initial is the electric potential energy in this formation. So we have U final minus 3KQ squared divided by L. Well, what is U final? Now, just for simplicity, you could do this one of 2 ways. You can do the way I'm going to show you, and you can think about it, or you can write them all out and do KQ1, Q2 divided by R, you know what I mean, and do it that way. But you have to realize, on the top, K times Q squared is just a number. So I have some number divided by a distance, plus a number divided by a distance, plus a number divided by some distance. Well, after a very, very long time, we're going to think about it as they go to infinity. Nothing stops them. They keep moving. There's no gravity. There's no friction. There's nothing. So this is 0. This is 0. And this is 0. Therefore, U final equals 0. Now, so delta U equals negative 3KQ squared divided by L. Now, all you have to do is just plug in. So plug and chug. Delta K equals negative delta U. I have mass velocity final squared equals negative 3KQ squared divided by L. Oh, it's negative here. These negatives cancel out. So I have velocity final equals 3KQ squared divided by L divided by M. And I take the square root of it. And that is the final answer. If you want to know how I got to there, just basic algebra. Multiply both sides by 1 over m. The m's cancel out. And then you have to take the square root of both sides. So technically you get a plus or minus, but we're not concerned about a negative velocity. So it's just this. If you have any questions, please let me know in the comments. I'm more than happy to answer them. Thank you for watching.